So this topic is also already they are familiar uh, who had mathematics in plus 2 level. So let's go through the basic concepts on set. Set literally the meaning of the term set you are familiar, and you used to use this term very frankly, freely everywhere, like pen set, dinner set, with goods. You are familiar with the uses of the term set. In mathematics, this concept is little bit different. Just collection of some objects we used to use always as a set. Collection of some objects, some elements. We used to say set. But in mathematics, it is a little bit different. So we used to have so many collections in day-to-day life. Collection of any goods, collection of some numbers, collection of some places, collection of some members, collection of some students, collection of some infrastructures, collection of some utensils. So we are familiar with the term collection. It's just a collection of some goods, some objects, or some elements. So we are familiar with the term collection. So set is also a collection. Set is also a simply collection, but uh, there is a certain condition, that is whatever you collect in the collection, that must be well defined. Well defined means what you are going to collect, that must be distinctly defined, so that at the time of collection you do not face any confusion, you do not face any problem. You comfortably pick up that object, that element, that good. So this is the meaning of well defined. When objects to be collected are well defined, then the collector do not face any problem. Collector do not have any problem to pick up the elements, to pick up the objects, to pick up the goods for the collection. So that is well defined. So that's why in mathematics it is defined that any collection of some well defined objects is called set. So collection of, you can write, you can note, the collection of well defined objects is called set. In examples, you can say yourself so many examples. Collection of students of your class, collection of books of library in your college, collection of vowels from the English alphabet, collection of prime numbers from 0 to 100, 0 to 50, whatever you say, collection of some, you can say, animals from the planet, collection of odd numbers, collection of even numbers, collection of ministers, collection of members. So these types of example you can say, because in these examples you do not have any problem to write the elements, to have the objects. It's a collection of students of our class. So it is no problem, because elements are well defined. How many students are there and who are there in the class. So it is distinctly defined. Collection of vowels. So it is distinctly define the vowels which are lying in English alphabet. So we do not have any problem to have the elements, to have the objects, to have the goods. So we do not have any problem. This is well defined. A quadratic equation, suppose given, it is there in the screen, x square minus 5x plus 6 is equal to 0. So quadratic equation, it has always two solutions, two roots. If we say the collection of roots or collection of solutions of this equation, that is also well defined, because equation is given means roots are defined. Solving the equation, we can have roots, and here roots are 2 and 3. So it is a set, and this set contains two elements. What are these? 2 and 3, because it is a collection of solutions of this equation. If I say collection of natural numbers between 1 and 10, between 1 and 10 natural numbers. So between 1 and 10 natural numbers, that is 2, 3, 4, 5, 6 up to 9. That means it is well defined. So it is well defined, that's why it is set. We do not have any problem. Now we come to some collections which are not set. There are some collections which we cannot say as set. Like say collection of new Hindi films. Collection of new Hindi films, it is not set, because which is new film and which is old one, you cannot define it. So collection of new Hindi films, it is not well defined. Which is new and which is older one, exactly from which date. After that date, whatever films released, these are known as new. Definitely not. So that means this collection is not well defined. Collection of, suppose, intelligent students from your class. Collection of intelligent students in your class. This is collection, but it is not well defined. And that's why mathematically we cannot say it is set. Literally, usually you can say that these few students are brilliant students of our class. We can say. And sometimes on the basis of scores, basis of marks, on the basis of mark sheet, few students might be picked up as brilliant students. But that is in mathematics it is not set. That may be a collection simply, since it is not well defined, because intelligence of the students cannot be measured, and there is no specific number, specific value that which values can be, intelligence can be converted in terms of that particular value. So that is quantification. We cannot quantify this. So that's why it is not well defined. Beautiful girls of your class, of your college, of your university, it is not well defined. Who is beautiful, who is not, who will decide this? And there is no yardstick to measure in terms of numbers, that she is beautiful, this person, she is beautiful, this person, she is beautiful, this person. It cannot be converted into quantity. So it is not well defined. That's why you cannot say this is set. Similarly, collection of handsome boys. Collection of handsome boys of your class. We cannot say it is well defined. Collection of wise men in our society. Who is wise and who is not wise, who is foolish, who will decide it? How will decide it? So it is not well defined. So these are not set in mathematics. dangerous animals, collection of dangerous animals in the planet. Which which animal is dangerous? Who will decide it? So, at a certain moment, for certain people, a cockroach might be dangerous. Even then, a snake or tiger. So, dangerousness of animal we cannot define properly, and that's why it's not set. Collection of good cricketers, collection of 10 best batsmen, collection of 10 best batsmen. It is not set. How will decide who is the best? It is definitely in terms of scores. So, up to what score a player can be defined as best? There is no certain yardstick, so it's not set. So, I do hope you can now understand, though you are familiar with the word collection and you know collection, but all collections are not set in mathematics. Now, I do hope you can understand what is set. So, set is a collection of some well defined objects, and we say it is elements. Now, it is new, it is a collection. So, definitely new thing. So, there will be definitely some way to express it. How we write set, how we represent sets. Definitely, representation will be there because we need its expression. How is to use sets? How it is represented? How we will represent sets? How many ways it can be represented? Basically, two ways represented. And before that, some standard sets which are standardized in mathematics with some block letters of the English alphabet, standardized always, like N, capital N here in the screen, capital N. Capital N represents always set of natural numbers. Capital Z, sometimes capital I, set of all integers. Q, capital Q, set of rational numbers. Capital R, it is always set of real numbers. Z plus, all positive integers. Q plus, the set of positive rational numbers. R plus, set of all positive real numbers. These are standardized in mathematics. In set theory, these alphabets represent always these sets specifically. Always N indicates natural number, set of natural numbers. Similarly, Z always indicates integers. Sometimes in some books, some authors use capital I for integers. So similarly, Q rational, R real, and complex number is there, and complex number is set of complex number is represented by capital C. It is not given here. Anyway, these are just like a name of some standard sets. So basically, to represent set, to entitle a set, a collection, we use always block letters. Block letters of English alphabet. Like suppose we have collected few numbers within bracket to represent set, and suppose we need to entitle this one. We used to write capital A, B, C, X, Y, Z like this. So block letters we usually use to represent set. Now let's be familiar with a symbol. You see here in the screen, this line you say, if A is an element of a set A capital, we say A belongs to A. That means when an element lies in a particular set, then literally we say the element belongs to the set. The element belongs to the set. So if set is capital A and one element in this set is small a, then we literally say A belongs to A. That means small a lies in the set A. And this is mathematically symbolized as this one. You say here, we write A belongs to A. You just observe the symbol. The name of this symbol is epsilon. This alphabet from Greek alphabet, this symbol is uh, here associated from Greek alphabet. This is epsilon, and here epsilon A. That means A is lying in the set A. Small a is lying in the set capital A, and it is read as A belongs to A. We do not read A epsilon A. We read as A belongs to A. That means small a belongs to capital A, set capital A. And suppose B is any element, B is another number which is not A. Which is not A. If a number or if an element which is not present in the set A, which is not present in the set A, that means that is not element of the set A. We read literally the element does not belong to A. We say literally the element does not belong to A. And suppose here B is the element which is not belonging to the set A. That is written mathematically like this. Just epsilon sign is cut obliquely. It is just symbolized as does not belong. So we read as B does not belong to A. That means B is not an element of the set A. B is not element of the set A. We read as B does not belong to A. And it is written as this one symbolically B epsilon cut then A. B does not belong to A. That means B is not present in A. So this is about a just symbol to express. Suppose capital N is the set of natural numbers always. Natural numbers are 1, 2, 3, 4, 5, 6, so on. 0 is not natural number. So if we have to express this symbolically in such language, we will write 0 does not belong to N. In such language, we say 0 does not belong to A. Definitely we will write like this. 0 belongs epsilon cut then capital N. That means 0 does not belong to N. This is the just symbol in such language you should know. So I do hope you have understood the applications of this symbol epsilon. Literally read as belong to. Okay. Now After being familiar with the symbol epsilon, uh, we discuss about the types, in which forms we used to represent set. How we need to represent set. There are two types. There are two types. One is roster or tabular form, another is set builder form. So two types are there. First one is roster or tabular. Second one is set builder. In these two types, two forms, we need to express set. Here it is first form. If we discuss about the first form, roster or tabular form, then you will see it's very simple. Here, just we need to write the elements within second bracket. Second bracket is strictly essential. No any other brackets allowed to write the elements of a set. So if within second bracket we write elements using comma, that is representation of set in tabular form or roster form. Here in this screen you see the set of all natural numbers uh, divide 42. Is this not this one, not this one? Inside this one, 246. Say here, 246. Here within second bracket is written within second. So this is an expression of set 2 comma 4 comma 6. In this representation, you just observe second bracket is here and next comma is used after every element, because this comma distinguishes the elements. So comma is very much essential along with second brackets. So just in roster or tabular form, we need to observe that when we write the elements, it must be inside the second bracket, number one. Number two, every element, that means between two elements, comma must be there to distinguish the elements. So this is the observation to express a set in roster or tabular form. Okay, so that's all for today. In the next class, I will continue with this representation of sets, roster and set builder. And for today, this much on set. And I do hope you have understood clearly. And whenever you go through any particular book, as I told you back, definitely it will be clear and it will be understandable for you very easily. So thank you so much.